Here we are in Unit 1, Activity 7, Question 5. Part A asks us to find the equation. The equation was given to us once we went through the steps in Part 4. You'll notice that it gives us a bunch of bulleted steps. When I did these steps here in the calculator file, it gave me what said linear regression bx, and it gives me various answers here. I can combine these three squares, if you will, and create the equation. So the A of the equation from right here is given to us at 67.2827. The B is 6.78446. So to answer the question in part 1, we need to put all these parts together. So the equation is y equals 67.30. I got that from right here. And then this $6.80 is from right here. So there is your equation for the line. Part B asks us, interpret the slope. What does the B represent? What is the part that's multiplying with the x? What does it represent in this particular problem? So here it is right here, and here it is right here. So it's the part, this number right here is being multiplied by x. Where do we get this $6.80? What does it mean in this particular graph, if you will? So that $6.80 represents something. So what do you think it represents? And you might want to come back here to the internet, and I have a few pictures of slope. So here's the slope. It's a number that's multiplied by the x. Notice here it's in front of the b. And I'm given some change in y over change in x. This particular picture might be the best help to answering the question. And here it is again. So the slope is the rise over the run. It's the change in y and the change in x. And so here we're going up $6.80 every time we move forward. So what does that $6.80 come from? Part C now. Very similar question. It says, where's the y-intercept or the A come from? And again, in our particular example, our A is $67 and about 28 cents. Maybe I should revise that. So where does the $67.28 come from? What does it mean? What is it doing in this equation? I might call your attention to this part right here. And you might want to notice that the approximate beginning cost, that might help you out. It's related to these numbers somehow. The last question here in 5, part D, it says, suppose you could replace waterworks with another property. What cost would be predicted by the line for the property at this location? So what it's asking us here is if we come back to this particular table, and we go to Waterworks. Waterworks shows up at the 28th square away from the Monopoly board's Go. And so if I come here, you might see here that if I move 28 spaces, this might be Waterworks right here. So I imagine if we kind of keep moving around, this is going to be 28 squares away from this Go. So we're wondering if we were to put a property here, how much it would cost. Well, the way we do that is you come over here, and we're going to put our starting amount, $67.28 plus $6.80 times the number of squares we moved away, which I think in this case is 28. And so I'm going to go ahead and press enter here, and it'll give me the value. But what I'd like for you to do is go ahead and type this into your calculator, or you're welcome to do it mentally. What is the value? What would a property cost using our equation that's 28 spaces away from Go? Here's your answer. But again, I need you to give me a total dollar amount by calculating this.